Okay, I'll be doing exercise 6.2, question number 6, as per request of one of the students. Okay, it's just a remake. So, my method, I don't know how Sir Rajesh did, I kind of forgot. But if my method is different from Sir Rajesh and you already understood Sir Rajesh one, then you don't have to do this. You can do that also. But if you did not understand that, you can do this, or whatever method you find it easier, you can do that. Okay, it's not just me and Sir Rajesh method. There, tuition teachers be as well. Whatever method you find it easier, just do it. It's okay. It doesn't matter. I'll give you marks and everything. So, the question is, PQ and RS are two mirrors placed parallel to each other. Okay, so these two is parallel to each other. An incident ray, so the incident ray is AB, strikes the mirror PQ at B, and blah blah, reflects all the stuff. Okay, the light is reflected back here and it's reflects and goes. We have to prove that AB is parallel to CD. So that's the question. I'll just write the answers here. So before we start, let me introduce to you the concept of incident ray and reflected ray. Okay, angle of incidence and angle of reflection is simply, suppose there's a reflecting surface, okay, and you put you shine a light there. So what happens is the light gets reflected, since it's a reflecting surface, like suppose a mirror. Okay, the light is incident here and then it gets reflected here. So if you draw a line parallel to the reflective surface, okay, perpendicular, not parallel. So perpendicular means 90 degree. Okay, 90 degree ekta inaka draw korisu, okay. So what happens is, by property of reflection and property of light, okay, what happens is this angle, which is called the incident angle of incidence, will always be equal to this angle, which is also called the angle of reflection. So angle of incidence means that it's coming, so it's called incidence, and then it's reflected back, so it's called angle of reflection. So this angle which is met with the light making an angle with the normal, this is called the normal. Okay, normal is always 90 degree with the ground. So this is an imaginary line. Okay, so with the ground, if you draw a normal that is 90 degrees to the ground, the light, wherever it's reflecting and going, the angle with which it makes with the normal, and the reflected ray with which the angle met with the normal will always be same. So if this is 30 degrees, this will always be reflected at a 30 degree to the normal. If this 60 degrees, the reflected ray will also reflect at 60 degrees. So that is like it's just the nature of light. That's how light works. Okay, so when it comes and reflects at any reflecting surface, it will always reflect back at the same angle with which it came with the normal. Okay, so this is the angle of reflection, angle of incidence and reflection, and they will always be equal to the normal. So since this is the angle of reflection, this is a reflected ray, like I've shown you, this is like this only, angle of reflection as a reflect kona jayes na. So if I draw the normal here, which is 90 degree to the base, okay, let's say this normal. If I draw the normal here, and since, see, this is the angle of incidence, right? It's the angle of incidence also, and then this is the angle of reflection because this came and then it's being reflected back. But the reflected light now becomes the angle of incidence for this reflective surface. For this one, this is now the angle of incidence, and this is the angle of reflection. So if I draw a normal here also, which is 90 degree to this one, not this one, but this one, since I hope you're getting it. So now the angle of incidence becomes this. This is the angle of incidence, and this is the angle of reflection for this light, right? So let's say in this case, angle of reflection incidence, let's say W, X, Y, Z. Let's just name that for timing. Now in the question they've already given us that this two is parallel, so I've given what is parallel. I hope you understood the concept of angle of incidence and reflection. So kuntu ayah je itu our reflection itu, so itu tidak same aja, itu tidak same aja. Or maybe let's do this, let's forget about W, let's make this as X and X so that it will be less confusing. Equal like angle of incidence reflection, so let's make this as Y and Y. Okay, I think that will be way easier to understand. So X, X, Y, Y. So our goal is to prove. To prove is we have to prove that AB is parallel to CD. Okay, so proof. Okay, so my target, okay, my goal, see, in order to show that AB is parallel to CD, before we show the parallel thingy, I hope you all know what is alternative angles. If I draw any parallel line, okay, I know you already know, but just for as a kind of revision, and if I draw any line intersecting two parallel lines, then this angle and this angle is always going to be same. It's called alternative angles. It alternates this one and the opposite, the alternate one, this one, not the same one but the other one. These two will always be equal. Doesn't matter if the line is this way or this way, doesn't matter, okay, or even if it's this like this, it doesn't matter. This and this, the alternating angles, this and this, the alternating angles, even this and this, ituwala, 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 okay, this and this, or maybe even this and this. So whatever it is, the one side and the other side will always be equal. So it not just works this way around, but it works the other way around also. So if there's a line, you don't know if they are parallel or not, but if you do know that this angle and this angle is equal, then you can definitely say for sure that this and this is parallel. Okay, which means if two lines are here, you don't know this line, if these lines are parallel or not, okay, but you do know that this is 60 and this also 60, then guarantee to ini kubaro itu tidak parallel because alternate angles are equal. Okay, so I'm gonna try and do this for this one also. So AB is here, CD is here, and since one line is joining here, if I can somehow show that this and this is equal, just like this is parallel, just like this, if I can show that this and this is equal, then we can say that this and this is parallel to each other. So that's what I'm planning to do. Okay, that's our goal. So proof, let's start. First you have to write okay, before this let's write construction. Draw normal means 90 degree, remember that. BN, so let's name this as N, and CM. So this is called a normal ray, which is 90 degree to the point of contact of the light and the reflective surface. Okay, this is called a normal, and normal is always 90 degree, don't forget it. So draw normal BN at CM. So after contraction you're going to write, but PQ and RS is parallel, which is given in the question, right? So see, next concept you have to know is, if these two is parallel, these two lines is parallel, it literally means that the distance between this and this will always be same no matter where. You calculate from here, you calculate here, you calculate here, you calculate here, whatever how distance you take, the distance between those two lines will always remain the same. Got it? So when you, provided that the distance you're finding is 90 degrees to each other. So if you draw a line which is 90 degree here, 90 degree here, and you draw anywhere the same way, 90 degree, 90 degree, these two will always be same. Of course, if it's straight line and you're drawing like this, and then you're drawing distance to Allah, but if you're drawing straight here, 90 degree, 90 degree, then distance between this and this will always be same, right? Length. And it will always be same. So since it will always be same, it will also be parallel to each other. Why? If you ask, since these two distance will be same and this is parallel to this automatic becomes a parallelogram, and parallelogram means opposite sides are always parallel to each other. Okay, let me repeat that again. Parallel is there, these two is parallel. If I draw a 90-degree one here and a 90-degree one here, it literally becomes a rectangle also. So opposite sides to equal over and parallel over. Opposite sides होता है parallel है. So but BQ and RS is parallel. Therefore BN should also be parallel to MC or CM, whatever it is. This and this should also be parallel to each other. Okay, so let's write. Let's start the proof. Let angle ABN equal to angle CBN equal to X. I'm taking XX. So angle of incidence. Why can we take both of them as X? Because as far as we know, X is an unknown variable, so we literally can we usually can take the value of X as only for one thing, but now we're taking for two things because they're equal, so we have to write why they're equal, right? So angle of incidence is equal to angle of reflection. And angle BCM equal to angle DCM equal to Y. Same reason. Okay. Let's keep this as equation 1, 2. Now we can say that, see, if you look at the diagram, we just literally said that this and this is parallel, right? So if this two is parallel, if I turn the diagram like this, you can see that it's forming a Z shaped here, which means those are the two alternative angles, because if this two is parallel, then the alternative angles will always be equal, right? So now angle CBN equal to angle BCM, alternate angles of BN parallel to MC. Got it? Since BN is parallel to MC, this and this will be alternate angles. So since it's alternate angles, they are equal. So X equal to Y. Therefore, from 1, let's make this 3, 2 and 3, angle ABC equal to angle BCD. Bracket, that is 2x equal to 2y, because this is theta x equal to theta y. So since x and y is equal to x to y, so this and this is equal, hence AB is parallel to CD. I don't know if you understood that or not, but let me just repeat it a little, the last part. Okay, so we just showed that this and this is equal, this and this is equal, angle of incidence, reflection, this, but we showed this and this is equal. So if this and this is equal, then everything will be equal, this 4 also. And we needed to show that this angle, we needed to show that this angle and this angle is equal, so that it becomes a Z, and this is parallel. So this angle will be 2x, this angle will be 2y, but then we just show that x and y are equal, so these two angles should also be equal. So that's exactly what we did. Okay.